Okay, here we are at Unit 8, Objective 4. You can see what I'm starting off with. I'm starting off with the special right triangles of 30, 60, 90, 45, 45, 90, and the other 30, 60, 90. I have them placed in standard position. You can see that if they were in the unit circle, this is where 0, 0 would be, right here, and right here, and right here. Now, I have them filled out with both sets of numbers. In the black numbers would be the regular 30, 60, 90 rules, 1, 2, and square root 3. And the 45-degree triangle would have 1, 1, and square root 2. Those are the black numbers. But the blue numbers would be, what if this triangle had been placed in the unit circle? Because we know in the unit circle, the radius is 1. So again, that 2 would turn into 1 by dividing everything by 2. Same thing with the 30, 60, 90 with the 60 right here, and the 45, 45, 90. So you can see the blue dimensions of the triangle are standardized as if the triangle were placed in the unit circle with a radius of 1. You're going to want to make sure you understand both ways. Now, over here, a simple review of the quadrants in which the trig functions are positive. All students take calculus, all sine, tangent, cosine. So, part 1 of Objective 4 is pretty easy, actually. All we're doing is indicate the quadrants in which the terminating rays for theta could lie. So all we're saying here is, what if the cosine value of theta were less than 0? So that would be negative. Where do you find cosine values that are negative? Well, they're positive here in 1, and they're positive here in 4. So it would be quadrants 2 and 3. Where would you find sine values of theta to be negative? Well, positive here, so negative here, so it would be 3 and 4. Quadrants 3 and 4. Now, where would you find tangent values, tangent squared values of theta to be negative? Well, it's tangent squared. Anything that is squared would turn positive even if it started off as being negative. So there are no places where tangent squared theta would be negative. Now, where would sine squared theta be? Kind of for the exact same reason why this is nowhere. This is all 4 quadrants. Because even if it started off as being negative, when you square it, it's positive. So all 4 quadrants. Now, here's where some students think the unit starts getting a little rough. We start solving for values of theta, depending on what its trig function is. And we're going to solve for values between 0 degrees and 360 degrees. So if we have an equation that says 2 sine theta plus 1 equals 0, we're just going to start solving it algebraically like we always would. The first step is going to be subtract 1. And now we would be at 2 sine theta equals negative 1. Now the next thing you would do is divide both sides by 2, and you have sine theta equals negative 1/2. Now, at this point, you got to get a reference angle. We're looking for what angle of theta has a sine value of -1/2. Well, let's worry about the negative in a minute. Let's just think about 1/2. Let's go back to our triangles. Which of our special right triangles has a sine value of 1/2? And it turns out to be this 30-degree triangle right here. Because if you use the black numbers, sine is opposite over hypotenuse, and there's your 1/2. If you use the blue numbers, it's 1/2 over 1, which is still 1/2. So the numbers don't change. So it's definitely a 30-degree angle that has a sine value of 1/2. Now what that tells us is the reference angle is 30 degrees. So that's the next thing we jot down right here. The reference is a 30-degree angle. However, the next thing we have to take note of is the fact that the sine value is negative. So we have to figure out what quadrants would these terminating rays be. Well, where is sine negative? It's positive right here. All students, it's positive right here. It's negative right here, and it's negative right here. So I'm going to make a 30-degree terminating ray right here. And I'm going to make a 30-degree terminating ray right here. Remember, the terminating rays, or the reference angles, are always off the horizontal. So this is 30 degrees right there, and that's 30 degrees right there. Now, the only thing we have to figure out now is, what are those real degrees? Theta would equal, I start right here, I'm going around 180 degrees to get me right here, and then I'm going 30 degrees more, so that would be 210. Now on this one right here, I'm just going to, first of all, I'm going to go all the way around to 360. So 360 would get me all the way around, but then I'm going to subtract 30 because I didn't quite make it there. So it's 360 degrees minus 30. So that's 330 degrees. So those are my two answers to this example problem A. We're going to practice a few more of these. Now in example problem B, my equation is 6 cosine theta plus 3 square root 2 equals 0. I've got my two terms right here that do share a common factor of 3, so I'm going to factor out a 3. And that's going to give me 2 cosine theta plus square root 2 equals 0. Now, what I'm going to do at this point is I am going to divide everything by 3. No, I'm not going to do that. I'm going to do something different. I'm going to set each of these factors equal to 0. 3 equals 0. That doesn't work, so that isn't going to take me anywhere. But the other one, 2 cosine theta plus square root 2 equals 0, that's going to take me somewhere. But let's just understand right now, the reason I decided to just factor out the 3 and then set each of the two factors equal to 0 is because now you can see this isn't going to take me anywhere. 3 actually does not equal 0, so I'm done with that part of the problem. All I need to do now is solve this part of the problem. So the first thing I'm going to do is subtract square root 2 from both sides. And I've got 2 cosine theta equals negative root 2. Now my next step would be divide both sides by 2. and I've got cosine theta equals negative root 2 over 2. Now, there is a reference angle that we know, one of our special right triangles, that has a cosine value of root 2 over 2. And we just have to look back at those triangles, and we find that it's the 45-degree reference triangle. It's root 2 over 2, 45 degrees, so that's my reference angle. We're doing cosine. I pointed to sine, but really cosine's the same thing, adjacent over hypotenuse. So root 2 over 2 over 1 is still root 2 over 2. So it's a 45-degree angle. My reference angle is 45 degrees. But again, it's negative. So which quadrants have negative cosine values? Well, quadrant 1, everything's positive. Quadrant 4, cosine is positive. So it's quadrants 2 and 3. So I'm going to do a 45-degree reference angle in those two quadrants, in quadrant 2 and in quadrant 3. Those are my terminating rays. Reference angles are always off the horizontal, so this would be a 45-degree angle right there. That would be a 45-degree angle right there. And now we just have to figure out what are those real angles. So the first one would be, I'm going to go all the way over to the other side, which would be 180 degrees, but then I'm going to back off 45 because I actually didn't make it there. So 180 minus 45 is 135 degrees. That would be that one, the upper one. And then the lower one would be 180 degrees plus 45, which would be 225 degrees. A quick look at example C is going to tell you that that is not factorable. So I'm not even going to try to factor anything out of this. I'm just going to start solving by multiple step algebra. So the first thing I'm going to do is add 1 to both sides. And I'm left with 3 tangent squared theta equals positive 1. Now I'm just going to divide both sides by 3 to get rid of that leading coefficient. And I'm going to get tangent squared theta equals 1/3. Now the way I'm going to get rid of that square right there is by square rooting. So that's my next step. My next step is simply a square root step. And what that's going to leave me is tangent theta equals, now when I take the square root, it's going to be plus and minus. Now the square root of 1 is still simply 1, but the square root of 3 is square root 3. So in its unrationalized form, it's 1 over square root 3. If you want to rationalize it, you would say tangent theta equals square root 3 plus and minus square root 3 over 3. So let's go back to reference angles. What angle that we're going to call theta has a tangent value of root 3 over 3? As it turns out, the reference angle that has a tangent value of root 3 over 3 is the 30-degree reference angle. You can see it right here. Here's the 30-degree reference angle. And tangent is opposite over adjacent. So in its unrationalized form, it's 1 over root 3. And then if you rationalize that, it's root 3 over 3. So the reference angle is 30 degrees. Reference angle equals 30 degrees. Now the next thing, since it's plus and minus, we know we're in all 4 quadrants. So the last thing we have to do is figure out what would those angles really be. So let's do a quick XY axis right there. And let's put in a 30-degree reference angle for all of those. Well, quadrant 1's easy. And as long as we're putting it in quadrant 1, we might as well put it in quadrant 3. So there's 30 degrees right there. And there's 30 degrees right there. Remember, reference angles are always off the horizontal. So when I do the other ones in quadrants 2 and 4, I'm making them off the horizontal axis. And there we go. There's 30 degrees right there. And there's 30 degrees right there. So what are all of those angles for theta? Theta equals, the first one is 30 degrees. The next one would be all the way over to 180, but then subtract by 30, and you'd get 150. The next one would be all the way over to 180, and then drop down 30 more, so add 30 more, and you'd be at 210. The last one, go all the way around to 360, and then subtract 30, because you didn't really quite make it all the way around. And that would be your 4 answers to theta for example C. Example D, as you can see by looking at it, example D has already been factored for us. So it's simply a matter of setting each individual factor equal to 0 and solving. So it's almost like it's a 2-part problem. We're going to work on the first part first. The 2 cosine theta minus 1 equals 0. We'll worry about the tangent part in a minute. Let's just solve this one. I would add 1 to each side, and I'd have 2 cosine theta equals positive 1. Now I would divide both sides by 2, and I'd have cosine theta equals positive 1/2. So, which of our special right triangles has a cosine value of 1/2? And as you look at it, it's the 60-degree angle right there. Cosine is adjacent over hypotenuse, and there's your 1/2 right there. So we know the reference angle is 60 degrees. Now, the cosine's actually positive, so let's figure out where those angles would actually be. The quadrants where cosine is positive is quadrant 1. Everything's positive in quadrant 1. Okay. And quadrant 4. So quadrant 1, my 60-degree angle would look like that. And then in quadrant 4, my 60-degree angle would look like that. Remember, reference angles are always from the horizontal axis. So there are my 2 terminating rays. And that would give me my 2 answers for this part of the problem to be really 60 degrees And then if I go all the way around, that would be 360, but I didn't go all the way around, so 360 minus 60 is 300 degrees. Now let's move on to the second part of the problem, the other factor, which would be tangent theta plus 1 equals 0. This is really only going to take one step because all I have to do is subtract 1. Tangent theta equals -1. I don't have a leading coefficient to divide by, so now all I have to do is worry about what angle, which of our special right triangles, has a tangent value of 1. One more look right there. Tangent is opposite over adjacent, and here it is right here, the 45-degree angle. Opposite is 1, adjacent is 1, so 1 over 1 is 1. So my reference angle is a 45-degree reference angle. And now we just have to figure out what quadrants are we in. Where is tangent negative? Well, tangent is positive. Everything's positive in the first quadrant, and it's positive in the third quadrant. So the negative tangents are in quadrant 2 and quadrant 4. So there's a 45-degree reference angle from the horizontal in quadrant 2, and here's a 45-degree reference angle. No, well, it is, but it's not from the horizontal. Here's the 45-degree reference angle from the horizontal in quadrant 4. So what are those real angles? Well, 180 minus 45 is 135. And the other one, go 360 degrees all the way around, but then come back 45 degrees because you didn't quite make it, and you're at 315 degrees.